Hello and welcome. I'm Ann Hitchcock and I'm a watchOS software engineer. Today, I want to show you how to create a productivity app on watchOS. Since the introduction of SwiftUI and independent watch apps in watchOS 6, you've been able to do more in your watch apps. Each year, SwiftUI on watchOS gets more capabilities. At the same time, watchOS has gotten new features like the keyboard that let you build whole new kinds of apps for watch. I'd like to show you how to knit together some of those features to build an app to track a list of things to get done. We're going to create a new watch app. Add a simple list of items to display. Let people add items to the list, and then edit the items. As we add these features, we'll talk about common app navigation strategies in watch apps and how to pick the correct one. We'll share items with a friend to share the load. Then we'll add a chart to our app to help us spot productivity trends and keep us motivated. And we'll use the digital crown to make our chart scrollable to show a larger data range. Let's get started by creating a new app. Create a new project in Xcode. In the watchOS tab, choose App and click Next. After choosing a product name, you have a couple of choices. The most important one is whether to create a watch-only app or to create a watch app with a companion iOS app. Let's talk about what makes a great watch app and when you want a companion iOS app. Great watch apps enable quick interaction, like the interface in Workout that allows you to start your favorite workouts quickly. No one wants to stand around holding up their arm, tapping through to find something. Great watch apps make it easy to access important information and features. Great watch apps focus on the essential purpose of the app. For example, the Weather app displays the forecast for today, relevant current conditions, and a simple 10-day forecast. Focus on the essentials in your app so people can easily find the information and actions they need. A great watch app is designed to be used independently of the companion iPhone. The Contacts app, for example, synchronizes with your phone, but doesn't require your iPhone to be nearby to access contact information on your Apple Watch. There are many reasons you might also want a companion iOS app for your watch app, including providing a historical record of data captured by Apple Watch or detailed analysis of trends, as in the Fitness app. Since our app has a focused feature set, quick interaction, and limited data, we're going to create a watch-only app. At this point, I want to spend a few minutes talking about the targets that are created. If you've built a watch app in the past, your project has two targets for watch: a WatchKit app target with a storyboard, assets, and perhaps some localization-related files, and a WatchKit extension target with all of your app code. These dual targets are a holdover from the early days of watchOS, and there really isn't a good reason for multiple watch targets anymore. Starting in Xcode 14, new watch apps have a single watch app target. All of the code, assets, localizations, and Siri intent and widget extensions associated with your watch app belong in this target. The great news is that single target watch apps are supported back to watchOS 7. You can simplify your project structure and reduce confusion and duplication while still supporting customers who aren't running the latest watchOS. If you have an existing app with a WatchKit extension target, it will continue to work, and you can continue to update your app using Xcode and publish your app through the App Store. If you already have a watch app that uses the SwiftUI lifecycle, transitioning to a single target is easy using the migration tool in Xcode 14. Select your target and choose Validate Settings from the Editor menu. The target collapsing option will be offered if your deployment target is watchOS 7 or later. If you haven't already made the leap, Now is a good time to start the process of converting your app to use the SwiftUI lifecycle to enjoy the simplicity of a single target watch app and all of the features of SwiftUI. The targets aren't the only thing we simplified in Xcode 14. We've also made it a lot easier to add an icon for your app by only requiring a single 1024 by 1024 pixel image. The app icon image will be scaled for display on all watch devices. Be sure to test your app icon on devices on the home screen, in notifications, and in the settings for your app in the Watch app on the iPhone. You can add custom images for specific smaller sizes if necessary. For example, if your app icon has details in the image that get lost at smaller sizes, you can add specific icon images for those sizes with the image details removed. Now let's add some functionality to our app by adding a list of task items. We'll start by creating a data model for our list of tasks. The list item struct will be identifiable and hashable, and we'll give it a description to display. Then, create a simple model to store our data and publish the array of list items. And finally, add the model as an environment object so our views can access our model. Now, let's create a list in SwiftUI with our data model. Since there are no tasks yet, when we preview this, we get an empty list. We need to do something about that. We should give people a way to add some tasks to their list. We'd like to add a button that people can tap to add a new item to the list. Text field link, new in watchOS 9, lets you invoke text input options from a button and offers several styling options to make it feel right at home in your app. You can create a text field link with a simple string, or use a label for a more custom button. Modify the button's appearance with view modifiers, including foreground color, foreground style, and button style. We'll create an Add Item Link view to encapsulate the styling and behavior of the text field link we're using in our app. We'll use a custom label for the button, and when someone enters text, we'll add the new item to our list. Now that we've decided to use text field link to add a button to add a new list item, we need to think about where to put the text field link. When adding actions to lists in Watch apps, we have a couple of options. Use a button, navigation link, or text field link at the end of the list for primary actions in short lists. Adding an action as an item at the end of a list is a good choice for a primary action in a short list of items, like the list of cities in World Clock. However, if you anticipate a long list of items, people will have to keep scrolling to the end of the list each time they want to do the action. For commonly used actions with longer lists, use a toolbar item. To add a toolbar item, add the toolbar modifier to the list, and use your action view as the content. This will add a single toolbar item to the list with automatic toolbar item placement. While I'd like to think I'll always keep my to-do list short, I'm fairly sure that I won't. So I'm going to put the text field link in a toolbar item to make it easy to access. Let's take a moment to review what we've accomplished. We've created a model for our list items, stored it as an environment object, created a list to display the items, and added a text field link to add new items. Creating an item with only a description is simple, but it isn't very useful. We're going to need to mark the item as complete, and we might want a way to set a priority or add an estimate of the amount of work for a task. To do this, we'll add a detail view. Before we do this, I want to review the options for app navigation structure in SwiftUI on Watch. Hierarchical navigation is used for views with a list detail relationship. Starting in watchOS 9, use the SwiftUI navigation stack to create interfaces with this type of navigation structure. Page-space navigation is used for views with a flat structure, where all of the views are peers. A great example of page-based navigation is the in-workout view of the Workout app, where people can easily swipe between the workout controls, metrics, and playback controls during a workout. A full-screen app has a single view that uses the entire display. This is generally used for apps like games and other apps that have a single main view. For a full-screen view, use the Ignores Safe Area modifier to extend your content to the edges of the display, and the toolbar modifier with a visibility value of hidden to hide the navigation bar. A modal sheet is a full-screen view that slides over the current view. It should be used for important tasks that should be completed as part of the current workflow. It's important to differentiate when to use a hierarchical flow versus when to use a modal sheet. Mail uses a hierarchical style to display the list of messages and show each message or thread as a detail view. There are actions you can do from the message detail, but there's nothing you must do before returning to the list. If you go back to the list and tap New Message, Mail uses a modal sheet to show the new message view. A modal sheet is the right choice because you need to fill in the details of the new message or cancel before continuing. To display a modal sheet, create a property to control the sheet presentation state. Set the property based on an action in the user interface. And use the sheet modifier to display the custom modal sheet content when the presentation state property is true. To add custom toolbar items to the modal sheet, add a toolbar with your items. Note that your toolbar items should use modal placements like confirmation action, cancellation action, and destructive action. We're going to use the modal sheet for our detail view because we're editing an item and we want to focus on this single task until we've finished and tap Done. To learn more about navigation in SwiftUI, including more details about navigation stack and programmatic navigation, check out the SwiftUI Cookbook for Navigation. Now that we've decided how to navigate to our detail view, we'll update our list item struct. We have new properties to store estimated work, creation date, and completion date. Let's give people a way to view and edit these details. We'll create a detail view with a text field to edit the description and a toggle to mark the task as complete or not. But what should we do with the estimated work? We know the values will all be numbers, and we can specify a range of valid values. Beginning in watchOS 9, we can use the stepper. The stepper is a great option when you want to provide granular control to edit sequential values. You can specify a range of values and optionally provide a step. You can also use the stepper to edit logically sequential, but not necessarily numeric values. For example, maybe we want to note the estimated stress level for an item. We could create an array of emoji to indicate the stress level. Then, create a stepper, binding the value to the selected index in the stress level emoji array, and setting the range to the range of emoji indices. Stepping through the values increases or decreases the stress level we're estimating for the item. Preparing a WWDC session is fun, but sharing great Watch app development with all of you is a party. When I have stressful items on my list, or just a lot of items on my list that are making me feel stressed, I'd like to share an item from my list with a friend to ask for help. We're going to add a button to our detail view to allow people to share an item using the share sheet. I want to be able to tap a button on my detail view to share the item, pick from a list of friends to ask for help, edit my message, and send it. To do this, we're going to use a new tool available to us in SwiftUI on watchOS 9, Share Link. We can share our list item by creating a share link with our item. We can optionally customize the initial text of the message with a subject and message, and provide a preview to display the share sheet when someone shares the item. You can use Share Link to share from your SwiftUI app in iOS, macOS, and watchOS. Be sure to check out Meet Transferable to learn more details and options for Share Link. Now that I can track when I completed items and call for help to get things done, I'd also like to add a chart to see my productivity. I've chosen to use a bar chart because I have a single data series and distinct data values. A bar chart will clearly show this data on a watch display as long as I limit the amount of data I display at one time. We're going to start by adding the chart view to our app's navigation structure. I've chosen a page-based navigation strategy because there's no list detail relationship between the item list and the chart. Someone can swipe between the list and the chart at any time. To add the page-based navigation for our list and chart, let's start by creating an item list struct to encapsulate the list view. I moved the entire content of the content view to this new item list. Encapsulating the item list here will allow us to have simple, easy-to-read tab view code in the content view. We also need to create a struct for our chart view. I'll temporarily put in a placeholder so we can focus on our navigation structure before we build our chart. Now, we'll set up a content view with a page-style tab view with two tabs, the item list and the chart. Since we've set up our navigation structure, let's talk about how to build this chart. I know I could use a SwiftUI canvas and draw a chart, but starting in watchOS 9, we have an easier answer: Swift charts. Swift charts are also available on iOS, macOS, and tvOS, so you can reuse your charts anywhere you're using SwiftUI. We'll aggregate the data we want to chart and then let Swift charts display it for us. For our chart, we want to show the number of items completed by date. We'll create a struct to store the aggregate data for the chart. Then we'll write a small method to aggregate our list item data into chart data elements. Display a simple chart by specifying the data to display and defining the series from the data. We're using the date as the X value and the number of items completed as the Y value. To achieve the appearance I want on my watch display, I'm customizing the X-axis using the chart's Chart X-axis modifier. I'm specifying a format style for the axis value labels. I also don't want vertical grid lines, so I omitted an axis grid line mark. I'm also customizing the Y-axis using the Chart Y-axis modifier. I specify a grid line style that looks good with my chart on watch. I'm formatting the axis value labels as integers and omitting the top label to prevent it from being clipped at the top of the chart. To learn more about the amazing things you can achieve with Swift charts, check out Hello Swift Charts and Swift Charts Raise the Bar. Our chart looks pretty good, but I'd like to show a little more data but still keep a great watch experience. So I'm going to make it scrollable. To accomplish this, we're going to use a new digital crown rotation modifier that allows us to set a callback for digital crown events. And we're going to implement a custom scrolling behavior for our chart. Let's get ready to add the digital crown rotation modifier by adding some properties to store the state as someone scrolls across the chart. The highlighted date index is the index of the data point for the current scroll position. We'll store the crown offset so we can display the current crown position as the person is scrolling across the chart. This is an intermediate value, on or between data points while the crown is moving. To keep track of whether someone is actively scrolling, we'll store the idle state. We'll use this information to add a little animation as the crown scrolling stops and starts. Now that we have the properties to store values, we can add the digital crown rotation modifier. We'll bind the detent value to the highlighted date index property. In mechanical terms, A detent is a mechanism that holds something in a position until enough force is applied to move it. For instance, when I open my car door, there is a stop position where the door will settle. I can push a little harder and open the door wider to another stop. To close it, I need to pull hard enough to overcome the resistance to pull it out of the stop. Otherwise, it will spring back into that resting position. This is a detent. The stop for the car door helps us understand detent in this API. The detent is the resting notch position of the crown on your view. In the handler for the onChange callback, we'll set the value for isCrownIdle to false, since we know that the crown is scrolling. And we'll set the crown offset value to the current value to let us show the current position on the chart during scrolling. In the handler for the onIdle callback, we'll set the value for isCrownIdle to true. Now we can display the position of the crown as we scroll on the chart. To do this, we can use the rule mark from Swift Charts. A rule mark is a straight line on your chart. You can use it to display a horizontal or vertical line, to display a threshold, for example, or to display a sloped line. We're going to create a rule mark with the crown offset date value to display the current location of crown scrolling. Just to make this look a little better, I'd like to have the crown position line fade when the crown stops moving. It's simple to animate this using the isCrownIdle property we added. We'll add a property to store the opacity for the color we're using in the foreground style for the rule mark. And add an onChange modifier to the chart to animate the crown position opacity value change when the isCrownIdle value changes. Then update the foreground style for the rule mark to use the opacity. To display the value next to the bar on the chart as we scroll, we can add an annotation to the bar mark. We'll position the annotation on the top leading side of the bar when it's the last bar. Otherwise, we'll position it on the top trailing side. Let's take a moment to see what we've accomplished with just the digital crown rotation modifier, the rule mark in Swift Charts, and a simple SwiftUI animation. The final step to creating our custom scrollable chart is adjusting the data range for the chart as someone scrolls. Create a property to store the visible range. Create the chart data variable to provide the data in the range to the chart. When the highlighted date index changes, call a method to check the chart data range and update it if necessary. As someone scrolls across the chart using the digital crown, the chart will scroll to display the available data. Now we've finished implementing all the features we had planned. To learn more about the new SwiftUI features available in watchOS 9, check out What's New in SwiftUI. As you're planning your Watch app or your new Watch app features, think about what makes a great Watch app experience. While you're designing your app, consider your app navigation strategy to ensure that your app is easy and intuitive. And use SwiftUI for simpler and richer development options. Keep building great Watch apps. And remember, because of you, there's an app for that.